Hello, I'm Daniel. I'm a computer science teacher at the Universidad del Zulia. I'm from Venezuela. I used to teach at the Universidad del Zulia in Venezuela, now teaching at the Universidad Autónoma Chile. So we're going to talk about multiple linear regression or linear regression. Now, the advantage of this type of regression, also called general linear regression, is that we can have many input features to help us predict the output variable y. To do that, we need to build what is called a design matrix, which is a matrix where each row corresponds to one sample point and each column corresponds to one feature, with the first column being the constant one so that we can have an intercept in the first parameter. We're going to build a little sample here, a little example, where we know what the true values of the theta parameters are. We have two input variables and have the output variable y calculated like this. So we generate this sample of points, and we're going to try to estimate those parameters from this data. So we're going to use this equation, call it here the ordinary least squares equation, to estimate the parameters based on the design matrix, the data in the design matrix, and the labels or outputs vector y. So we're gonna this code here. So we have to translate that formula basically to Python. So we have this formula, this matrix multiplication, and we have to translate it into Python. So we start by transposing x, that multiplies x. We take the inverse of that numpy. Inverse function, multiply the result, the inverse, by x transpose again, and then by the vector y. That hopefully should work. So we comment to test our equation. Comment this, so we run the code, get some results here that are somewhat close to what we should be estimating, right? True values are these 0, -2, -3. This is somewhat close, 0.13, -2 something, -3 point something. And these are values we should get. Next, so we can visualize the results here. We can calculate the mean square error result, and we can visualize the result. Here we get a plane, of course, and we have the original data points. So this approximates the data points, even though the relation is roughly linear, there is some random error, so the points do not lie in a plane. So our plane cannot, there is a difference between our plane and each data point. Polynomial regression is simply, instead of having totally different features as each of the columns in the design matrix, we take the original feature and we take powers of it as if they were new features. So instead of building completely new features, we have the one original input feature we raise to different powers. So let's